Yeah.
Hello, everyone. My name is Fang Tao from China Jiliang University. Today, I'm honored to present my research on airborne organophosphate esters in offices from Hangzhou, East China, seasonal variations, influencing factors, and human exposure assessment. Here is the outline of my presentation. Let's start with the background. As you may know, organophosphate esters, OPEs, are chemicals used widely as plasticizers and flame retardants. The production has increased significantly, especially in China, which is the largest producer. In 2015, the global production of OPEs was around the global the global production of OPE was around 680,000 tons, with China contributing significantly to this figure. Offices are primarily spaces where humans spend a considerable amount of time, and inhalation is the main route of exposure to semi-volatile organic compounds, such as OPEs. However, there is a lack of data regarding the presence and effect of emerging OPEs in indoor environment. Recent studies have shown that emergency OPE can have various toxic effects, such as neurotoxicity and reproductive toxicity, expression of genes related to lipid and cellular metabolites. Therefore, it's important to study their characteristics of emerging OPEs in indoor air and assess the exposure of occupational populations. Emerging OPE differ from traditional ones by having longer chains, more stable, and lower volatility. This difference in physical-chemical properties suggests that their environment behavior might be different, which could affect how they distribute and how long they persist in indoor environment. And also, the seasonal variation of emergent OPEs may be different from a traditional one, as well as influencing factors. Then move on to our experiment one. We select 3 types of offices for our study, different in size, ventilation rates, and the number of electronic devices and furniture, which are potential sources of OPE. Here are the characteristics of the 3 offices. We analyze OPE in indoor air using HPLC MS-MS. Samples were collected using air samplers equipped with SPE cartridges, and the sampling was done from 2020 June to June 2021. The samples were collected every 2 weeks. And also the data about temperature and humidity were also collected. In our results, we found that TCEP, TCIPP, and TDCIPP were 100% detected. And in indoor air, the dominant compounds in office air is TCIPP, accounting for 97.4%, 95.7%, and 96.2% of traditional OPEs in the 3 offices, respectively. And we found the levels of OPE on Office 2 with the highest ventilation rates was significantly lower than that in Office 1 and Office 3. This highlights the importance of good ventilation in reducing indoor air pollutants. And let's take a look at the results of emerging OPEs. 5 compounds were detected. These are CDP, RDP, BP, DPP, BPA, BDPP, and TIPBP. No significant differences in the levels of emerging obesity among 3 or found among the 3 offices. And the levels of emergent OPE is 3 to 4 orders of magnitude lower than that of traditional OPEs. The BP-DPP has been detected for the first time in indoor air with the high detection frequency. We observed seasonal variation in the levels of traditional OPEs with the highest concentration found in summer and the lowest in winter. But no obese trends were observed for emerging OPEs. This suggests that the different environment behaviors between emerging OPE and the traditional ones. Then we also find the positive correlations between traditional OPE and the temperature, likely due to their higher vapor pressure. However, emerging OPE showed a negative correlation, possibly because of their lower volatility and higher affinity for the solid phase. So the generally lower vapor pressure and higher QA of emerging OPE are compared to traditional ones, rendering them less volatile and more likely to be distributed within the solid phase rather than the gas phase. The relative humidity also play a role. We found the positive correlations between traditional OPEs and humidity, suggesting that higher humidity levels might hinder the degradation of these compounds, leading to higher concentration in the air. But the negative correlations were found between the emerging OPE and the relative humidity. Also, in one research, the researcher have found the relative humidity could restart the reaction of rate of hydrogen initiant heterogeneous oxidation of gases TCIPP and hindered the gas TCIPP degradation. Let's take a look at in conclusion. Our study detected 5 out of 8 emerging OPEs in Office L. The detection of BT-BPE for the first time in indoor L highlights the need for further research. The distinct seasonal variation and the environment behaviors of traditional and emerging OPEs underscore the necessary for ongoing monitoring and risk assessment to ensure indoor air quality and occupational health safety. And the levels of traditional OPE decreases in the following order: the summer, autumn, spring, and then winter. But the no obvious trends were observed for emerging OPEs. And this has been published on EI, and you may download this paper through this link. Thank you for all your attention.